Good afternoon, everyone, and thank you very much for your time being here. So I am Keith Chen, managing partner of SNZ Capital. SNZ Capital is a crypto-native fund. We supported Ethereum in early days since 2015 with a lot of our OGs, including Hashi Capital, definitely. We are here today to just give this panel to discuss about Layer 2 and also the new technologies. So definitely as a crypto fund, our main mission, one is definitely to support the innovation. The second one will be like to facilitate the communication, to communicate between those projects, to community and the West and the East. So we dedicate to those missions in the past about 10 years. Today, we'll please welcome our founders here. So to start, I just want you guys to give a very brief introduction of yourself and also the project of you guys are doing. Yeah.
Hi everyone, I'm Mo from Brevis, and we are working on ZK coprocessor to enable new exciting use cases for blockchain.
Yeah, I'm Georgie. I'm from Stanford. I'm founder of Hinko, which enables private storage and execution environment for Ethereum and EVM dApps.
Hi everyone, I'm Fu Biao from Paddle Labs. I'm co-founder of this team, and we trying to use cryptography technology like synology pools, homomorphic encryption to library the data and the computation for the end users.
Hi everyone, this is Dennis from My Network, and I'm the Chief Security Officer. We, My Network, are using full homomorphic encryption to help secure the consensus of AI network.
Good. I think in early this afternoon, we have a lot of updates from the famous Layer 2s like a Polygon and also Stockware, and also just previously Arbitron and Sriram from EigenLayer. So in this session, we are more going to explore some of the new challenges and the new innovations in, in Layer 2 or beyond. So to talking about a lot of those innovations, I think we're gonna, explore different directions, but to better facilitate the conversation, I think I will dig a little bit more into each project of you guys. Then we're gonna take a little step back later on to talk about in general, the Layer 2 innovation and the trends. Hopefully at the end of the talk, I know some of you guys are developers. Hopefully their experience can give you some of hints and stuff. Let's start with in general, I think I want to set up the problem. So when you guys choose the direction or the problem you guys want to solve, right? So what kind of come to your mind why this is the problem you're gonna choose? And your solution and at a very early stage. Yeah.
Sure. So first of all, Layer 2s are amazing. Layer 2 blockchains, and now we're in this multi-blockchain world. One way to kind of look at this is that we look at the analogy in computer history, right? So like Layer 2s and this multi-blockchain ecosystem is like evolution from like a single core CPU to multi-core CPU, right? So like in computer history, you have the single core CPU. You can just like do one task at a time. And now we have like Ethereum and then multiple different kind of Layer 2 growing on top of Ethereum, where you can essentially parallel the capacity of this entire blockchain ecosystem. But there's a challenge. The challenge here is that every single one of these Layer 2s are still essentially blockchains themselves. And they share the same nature of blockchain because they're still deeply rooted in this distributed consensus systems. And the result of that is that just like CPUs are not good at certain type of computation, and for these Web3 CPU, which are blockchains, essentially the blockchain construct, they are also fundamentally bad at certain type of computations. And specifically, what are they? They are data-heavy, data-driven computation and very complex computation. You just simply cannot put that in smart contract and in blockchain directly. And one example that I always take is that if you look at every centralized exchange, you have this kind of a VIP fee discount where you trade a lot, and then based on your trading volume, in the next month you get a discount. But if you look at every single decentralized exchange, including Uniswap and everyone, none of them actually has this feature. The reason to do that is as simple as computing a user's historical trading volume directly on blockchain is prohibitively expensive. To do that on Ethereum, it takes about $40,000 in gas cost, plus like 4 hours of computation time. So even if you do it on layer 2, it is still prohibitively expensive. Now, how do you solve that problem, right? So, we need to kind of just like draw analogy again, the inspiration from the computer history, where, for CPUs, we actually introduced something called a GPU as a CPU's coprocessor to offload certain type of computation that is very hard to do on CPU to this GPU component, then return result back to CPU. And this is why we have amazing graphics. So this is why we have like machine learning models and all that stuff. So for blockchain, we also need to introduce a coprocessor. But the key thing here is that we actually need to maintain a trust-free nature of this entire computation cycle, where we basically kind of can still relay many of the computation of this special component, and then relay this result back to blockchain without any trust in this third-party component. So this is where Brevis comes in play, where we introduce a ZK coprocessor that enables various different type of computation and data access on historical blockchain data like events, states, and the transactions to entirely just compute it as off-chain, but we generate zero-knowledge proof to put it back on-chain for smart contract to consume. One simple way to look at this is basically you're enabling a Dune analytics dashboard for your smart contract, right? So like, if you're just looking at Dune analytics dashboard every day, they are for human and off-chain entities. But we're enabling that type of visibility and the computation capability for smart contract, and this is where we think we should push the frontier for blockchain.
So the key word here is like a ZK coprocessor.
Coprocessor, yeah.
Okay, great. Georgie.
Yeah, with L2s, we are currently arrived to the point where finally institutions can come to blockchains and have similar user experience that they have on centralized exchanges. They can move assets. They have composability of liquidity. And with this in mind, one crucial point that we are solving is privacy. So, but actually, I don't like calling it privacy. I prefer calling it confidential environment because privacy was a bad word used by bad actors before. And the way we approach this problem is how can we make sure we can plug in current liquidity, current DApp experience, and with one click of private mode, enable full confidential execution environment on your current dApps. And that's what we solved with Hinkle. So you can, swaps on Uniswap, provide liquidity on Curve, stake on Convex Beefy. Now we're adding Pendle as well. So you have end-to-end experience without withdrawing your assets with your private address inside smart contract. And this private address is compliant because we also use the term reusable attestation. So you can basically attest that you have done KYC somewhere in internet before, and you can reuse this attestation with Hinkle, proving that you are not a illicit actor. And then what we are focused on is removing all necessities for bridges, for separate liquidity, so you don't need standalone L2 to enable privacy, right, and private execution. You won't be copy-traded. And one more use case that we are focused on that actually is very relevant to the current market is private liquidations of tokens. So now with the bull market coming in, a lot of need is how can you liquidate tokens in a fully private environment, but also receive these tokens privately. And Hinkle enables this in also very compliant and fully confidential DApp set ecosystems such as Uniswap or OTC desks.
So I think most of the layer 2 solutions provide a nice scalability solution right now. And from our perspective, we think it's a time to pay more attention on the application layer. So that's why Paddle actually want to build something more relevant to the user's data. So because the logic is like in the traditional Web 2 economy, the user's data has been proven very valuable, and especially on the private data. And the Paddle's idea is we would like to create a a compliant and fully secure technical solution with the technology of cryptography. So for example, we think the user can truly control their own data by first they can retrieving their data from different Web2 data sources, and then they can freely share their data, which can help them to gain some benefits from that. So in our first step, we have built the ZK attestation solution, which leverages the technology of zero-knowledge proof, which can first guarantee the user's data is truly from that web data source, and also we can guarantee the user's data will be used in a privacy-preserving manner in different applications, and they can gain benefit from that. So a very simple example is, for example, you have some, say, some crypto assets in the off-chain exchanges, and traditionally you cannot doing that in different dApps. I mean, the exchanges, they just use this data for themselves, and the data cannot be leveraged or be shared with their on-chain smart contracts. However, with Pado's technology, we think it's possible to help the user to first prove their data in the centralized exchanges, satisfy some certain condition, and say, for example, they can prove their wallet balance in some exchanges is more than 1,000 USD, and they can show this proof to a decentralized application, and then they can potentially get some rewards from that. So this makes a very a new paradigm for the end users to leverage their existing web data. And of course, there will be some other challenges in building such kind of solution. For example, how we can guarantee the user is powerful enough to do this kind of data computation. For example, if the user using some mobile phone, and people know that generating some zero-knowledge proof is quite costly in such kind of resource-limited device. So in that case, we need to delegate this kind of computation to some external node. And how can we guarantee the security in that new data sharing process is another challenge. So to sum up, I think we have seen there are some more opportunity and their business chance to leverage the users' private data in Web3, while we can still keep that data safe and be more valuable to the end users.
Okay, great.
Yeah. From our perspective of view, we also think that keeping secret on blockchain is a big challenge. Because we know that in blockchain, we just achieve the consensus based on open information. We just broadcast the data, the parameters into P2P network, and everyone can get to access this information. This works well in traditional blockchains. However, when it comes to, for example, AI networks or deeping, there's a problem here. Because for AI networks, no matter the income parameter or outcome result, they are all very valuable, considering the computation power consumed. So the operator knows they don't want to their results to be copied or to be stolen by others until their result is officially accepted. So we cannot use just such kind of the open information in plain text. Then my network, we worked out a solution which is empowered by full homomorphic encryption. In our solution, the consensus of AI network or deeping network, they can be achieved from ciphertext. This eliminates the risk of the leaking secret. And our users, they can also stake their tokens in our FHE restaking layer, and they can contribute to secure the consensus of the AI networks.
Great, thank you very much. And I think the talk is pretty technical, but definitely I want to give some kind of like keywords to each of the projects. Definitely for Brevis, is ZK coprocessor, and for Georgie Hinkle, it's more like account-based, like a privacy wallet. And for Pado, I think it's more like a ZK FHE. And for my network, they're also using the FHE to build in their network. So that's, I think, the keywords for those guys. But to explore a little bit more of each of the projects, I'm gonna throw like specific questions to each of them. This actually cover like 3 different sectors. One is ZK, and the other one is privacy, and the next one will be FHE. Is a pretty new technology here. Definitely, I want to go with the Georgie first. So to you, definitely privacy, like you mentioned previously, used by a lot of those bad actors as, when you mention privacy in blockchain, usually people give like a really negative feedback. So, but definitely, I think privacy is a kind of like in my mind, is like one of the big issue we have to solve in blockchain anyway. Then to your point, now I think in between privacy and the compliance, there's a huge gap. I think people also talk about it, but in your point of view, how could we, what's your opinion about this kind of like a balance? How do you guys in Hinkle to balance this problem?
Yeah, definitely. It's a big issue, and we started Hinkle right after Tornado Cash sanctions. So it was our main priority. How can we combine both compliance and privacy? And then we have solved this with several layers of compliance, I would say. So first, we integrated several KYC DID protocols, such as ZKMe, Authento, so users can pass KYC or reuse previous attestations with those protocols. And second, when we realized that actually not all of our users have these attestations, we thought, how can we simplify even here user experience and enable more people to come on and enable mass adoption, right, without everyone just manually plugging KYC and KYB data. Though none of this KYC or KYB data is stored with us, right? I want to make sure that this data is stored either, like it's not stored anywhere with ZKMe, so it just like uses ZK solution for this, or it's stored with certified KYC providers, right, like Web2. And then in order to simplify even this user experience, we enable reusable attestations through centralized exchanges. So most of users have Binance, Coinbase, or other exchange accounts. So when we already added Binance and Coinbase, so users can just prove that they have Binance account, and now they're able to become private and have end-to-end confidential experience on their dApps they're using with just this attestation. And then every 6 months, per regulation, they just have to re-log in and prove that they still have this Binance account. And this way, we solve the problem of compliance, right? And then I think the second question here around compliance is how we can make sure that institutions that currently use Hinkle, feel comfortable using it and can share data about their transactions with their LPs, right? And to achieve this, we have built an attestation system inside the protocol where users generate, when users join Hinkle, right, they generate private address, and this private address is decrypted with private shielded key. And every time they do transaction on external dApps, they generate zero-knowledge proof to smart contract and stealth address, one-time stealth address, and then Relayer executes this transaction on external dApps. So the question is that if all this transaction is with ZK-based and no one knows who is the owner of this transaction, how can they prove to their LPs as well as to other entities that they want to share this information, let's say accounting companies, that they did these transactions? And for this, we have built a system where they can plug in viewing keys and automatically generate all data about their transactions and share with their LPs or with whoever they want. So it took us some time to build, but now it's live on 7 chains with 7 highest TVL dApps, and most of them are on L2. Actually, in fact, we have the biggest traction on Base And we see a lot of demand for private transactions coming from there, also because we removed all these barriers to adoption.
Thank you. The next question will be for Moore. I think in ZK space that evolving so fast, right? I think in the past few years we witnessed a lot of those even algorithm or other like hardware acceleration, all kinds of stuff. But one of the interesting thing you guys did, I think last year was the benchmark test. Yeah, just one quick question for you is how's that going, and what's your next like a plan on that benchmark test stuff?
Yeah, definitely. Happy to share more on that. So like, for the ZK benchmark thing we basically want to look at what is the landscape for, zero knowledge proof stacks today. Like what are some of the frameworks that the developers can use? Because like as Keith mentioned, like, there are a lot of changes over the last 3 years. That like a framework that might be the best choice in maybe just last year might not be so this year anymore. So we did a very extensive benchmark testing across all ZK frameworks, and I realized that the answer is definitely more nuanced, because like it really depends on what type of application and what type of infrastructure you want to build with each of these stacks. And generally, if there are any builders and developers in the audience, we generally find that Gnark from Consensus team actually offers very, very high performance, out of the box, and coupled with like, solutions like Ingoyama's hardware acceleration, it can really do magic. And this is like what we are kind of choosing for our stack as well, to optimize for both the algorithms to build the ZK coprocessor and also the system to make this entirely parallel and with multi-level aggregation, and finally with very strong hardware acceleration. The exciting thing about this is that the more we do this, we start realize that the ZK coprocessing and the ZK computing overhead is not as bad as many people would think, right? So before, like 1 year before, we should probably be looking at 1 million time inflation in terms of the amount of computation you'll be looking at for each of these ZK coprocessing and ZK computing for the same thing, right? But right now, I think we're pushing very, very close to 3 orders of magnitude, which makes many use cases very attractive. Like even for things like ZKML with cross-stack optimization to utilize certain properties of the machine learning model itself, and also combine that with a ZK design, proper ZK design to cater to that, you can actually achieve very, very close to native performance when you are also doing ZK proof of the model, which can bring a lot of exciting use cases to the table as well.
So how like a Brevis gonna use all those TK technologies in the coprocessor? Then, for example, nowadays people, I think in the research side or like engineering side, we talk a lot about like a folding scheme or like a new ZK EVM. So in Brevis kind of like a scope, how do you utilize that? Or what kind of technology you guys gonna exploring?
Yeah, we definitely, as mentioned, like we basically kind of tackle 3 different directions. One is on the algorithm side. We did a lot of the innovation in the algorithm side to kind of find the best kind of proving stack, and also the algorithm to do very efficient multi-layer aggregation. We're also doing a lot of work on the GKR stack to kind of make things super fast, for certain type of computation. But very importantly, we also want to make sure that while we are optimizing for specific type of circuit, we still maintain the generality of ZK coprocessor, right? So like because Brevis is a smart ZK coprocessor, you can use it to actually build and integrate it into your application in whatever way you want. You actually don't need to use any ZK circuit or write any ZK circuit to integrate that into your in your product. So that's one front. And then we work very extensively on hardware acceleration as well. So we actually kind of have our small cluster data center in San Mateo as well. So like that really helped in terms of like accelerating things. And finally, on the system side, right? So because we don't want to make sure, we just want to make sure that the entire system is entirely parallel. So when the load of the entire system is increased, we can keep adding load to this system stack as well. But finally, I think there is a role for crypto economics in the ZK coprocessor space as well. We're working very closely with EigenLayer to launch previous AVS and to enable things like crypto economic-based proposal plus ZK challenge architecture that is like going to bring the ZK coprocessing cost down a lot.
Thank you. For the next question would be for like FHE related. So for Dennis and also for Fubiao, you guys are working on FHE related stuff. So one question is for just for Pado. So currently, I think on the market there are at least like 3 companies working on FHE. So what's the difference of Pado you guys worked on, and what's the benefits all the other developers can get from?
All right, thanks. That's a good question. So FHE is, right now we have seen a lot of projects like Zama, like Phoenix, and maybe more pioneering projects bring this new crypto technology into this industry. So I think most of the interesting here is fully homomorphic encryption is quite powerful, and basically he can support arbitrary computation on the ciphertext. So just imagine you as a user, you have some private data and you want to do some computation, but if the computation is too complicated, for example, you want to contribute your data to a machine model training, then definitely your device will be not supportive, and then you need to delegate your computation to some other powerful node, so which is called outsourced computation. And the FHE actually can provide a very perfect privacy for this kind of outsourced computation paradigm. I think this is the most significant property which provided by the Zama or some other projects in this area. For example, they use FHE to provide the FHE-based virtual machine or FHE-based rollup or some other new blockchain design. And definitely this will provide a very nice and flexible privacy from the design perspective. And however, Pado's solution is called ZK FHE. So we know the zero-knowledge proof, technically, it can provide the scalability for some applications like Layer 2. However, an unusual fact is zero-knowledge proof, in some circumstances, it's not provide privacy. So it's quite unusual. Just considering a user want to generate as an art proof, and if the user, his device is not powerful enough, he will definitely delegate this proof generation to some other worker. And due to the security property of the art proof, if the worker doesn't know the witness, the secret information within this kind of proof generation, then the worker will not be able to generate the zero-knowledge proof. So in that case, the ZKP solution will not provide this privacy. But FHE solution, actually, people just care about the privacy, but it cannot provide the integrity. So in the FHE solution, the worker can do some outsourced computation on this private but encrypted data, but on the other hand, we cannot expect that the worker is honest enough. So the FHE guarantees that the result will be privacy preserving to that user, but the worker itself can doing something like a random response to this computation task, but you have no way to distinguish this random response from an honest worker. So in that case, we definitely need a kind of security called integrity within such kind of computation process. So that's why we, as Pado, we provide a new, I think new but also very, let's say, win-win solution of FHE. We call ZK FHE. Yeah, so we kindly can provide both privacy and together with the computation integrity during such kind of FHE computation. And also we were trying to provide some performance protocol design from scratch.
Good. The next question will for Dennis. So I think FHE is really like a good, new technology. So what FHE actually mean to you guys, and what you guys gonna use FHE as a network or in the architecture-wise? What are you guys gonna use FHE?
Yeah, just as Fubiao said, FHE is actually outsourcing computation. So this kind of outsourcing means two things for us and our AI blockchain partners. First is confidentiality, which I've just mentioned before. It's about the secret. And the other is about flexibility, which means with FHE, we can actually use flexible forms of consensus. This is important to AI, because for traditional consensus, they are simply they are very simple, and they just simply based on the exact match by comparing hashes. However, in the scenario of AI and the deeping, the parameters or the results, they normally are approximation. They are not exact values. This means that by comparing hashing, this simply doesn't work. And on the other hand, FHE, it can do this job very well. So we worked out our solution, and our solution consists of three major parts. One is the security layer. In this layer, we just use FHE computation nodes to compute the parameters of consensus. And of course, they are encrypted, so these nodes can freely joined by any third party, and the user, they don't need to worry about the leak of the secret. And the second layer is called the consensus layer. It is supported by EigenLayer. We use EigenLayer to enhance our own security. And since the computation of FHE is deterministic, so they can achieve their consensus in this consensus layer, which is an Ethereum rollup. And the third layer of our network is the FHE restaking layer. So the normal users, or the stakers, they can just stake their token in our restaking layer to help to secure our AI partners, our deeping partners, help their blockchain to secure their consensus. So that's our architecture.
Sounds great. I'm gonna jump out a little bit. So because I think in the past, half an hour, we just explored all those what all those guys are doing, but definitely we're exploring some of the new technologies and opportunities. So I think in the Ethereum roadmap, thanks for Vitalik and the Ethereum Foundation. So the roadmap is laid out really well. I think everybody can explore. But beyond that, for each of you, what kind of opportunities you saw, or like a new technology you guys see from there, and any kind of like a new technology or new trend gonna play a great role in the future blockchain development? Yeah, I will just like start with Mo. So.
Yeah, sure, definitely. So, I think, I'm mostly looking at this trust-free computing and, coprocessor and asynchronous computing space. And there are very exciting things that are happening. One thing is that ZK machine learning, right? So, people say that there is no use case for ZK machine learning, but the way I'm looking at ZK machine learning is, are really twofold. One is that it's really a test station and a showcase for the entire ZK community to say, okay, as long as you can process and deal with this type of large model, any type of computation then is possible in ZK, right? So, the push to the ZK machine learning space is very exciting because it introduces like this kind of arm race process to generate many, many new innovations in the ZK underlying space in both cryptography, in hardware acceleration, and also in the algorithm and the system side of things. So that's one thing that is particularly interesting. But another thing, I'm also very interested in, the second fold for ZK machine learning is that there are actual use cases that you can actually see today, right? So there is a large untapped opportunity in blockchain space today that is kind of active liquidity management or protocols that can manage liquidity on behalf of users, right? So, but like this type of things is just simply not possible without both the ZK co-processing capability and also the machine learning capability combined together. So yeah, that's something that I'm super excited about in the next couple of years.
Yeah, ZK machine learning. How about you, Georgie?
Yeah, I think there are two layers, right, that I want to emphasize. First is moving from transparency, and then, when we, for example, share about privacy, like regular users say, isn't it the core use case of blockchain to have transparency, right? Why would they need privacy? And I think we should shift our mindset completely from transparency to accountability, right? Because with privacy at place, your transactions are still on chain, so they're verifiable and therefore accountable. But they're not transparently coming from you, right? So there is no way for anyone, for Akraham basically, or for Nansen to dox your wallets and to show everyone, right, and run bots against you. And that's the biggest problem, right, in the educational piece, right, with this idealistic mind in place that Ethereum and Vitalik and Ethereum Foundation outlines. It should be always transparent, people should emphasize, but for real world adoption, that's not the use case, right? We want blockchain to become reality for every human, for everyone to just plug in wallet, or just even without knowing wallet, right, to be able to have verifiable transactions, composability of these transactions, and then derivatives from on top of that, right, with full ownership. And with this, we should completely shift our mindset. And second vertical that I would emphasize is adoption, right? So in Vitalik's roadmap, there is no mention of, how can we bring broader adoption to Ethereum and, EVM chains, as well as Altos, right? Outside of core, TPS improvement or technology improvement. But there is a lot of work to do, right, to emphasize this direction. How can, for example, BlackRock deploy like 5 billion assets instead of 200, right? And there are several primitives that should be met to enable this use case.
Good. How about you, Fu Biao?
Yeah, I think for talking about the new technology and new trend within the Ethereum ecosystem, so like Mo said, ZKML will definitely be an interesting new topic. And for me, I think another interesting thing about attestation, and also I think Henka mentioned that. So attestation actually is not only about the on-chain part. You can definitely claim your, for example, on-chain activities or on-chain reputations from the third-party issuer, but also you can bring your off-chain historical data to the blockchain as well. So also we can think about how, let's say, using the zero-knowledge proof or some other secure technology, we can truly prove our off-chain record and bring this kind of private data, kind of private oracle to the smart contract, and then we can really build kind of non-DeFi applications, which will be definitely more excited to the data-driven economy. So yeah, that's my pretty much my, yeah.
Dennis.
Yeah, I'm excited about two areas. One is BTC rollup, and another is AI rollup. One is the biggest blockchain, and the other is the most important new industry. And neither of them works well directly with EVM. So there are big challenges. But both of the rollups, they are very important to the Web3 world. Yeah.
Thank you. I think we are in the very last minute. I just want to give you guys like a very simple like a wrap up and like just how people can follow up with you. Yeah.
Yeah, feel free to follow us on the Twitter. Our Twitter account is Brevis_ZK. And yeah.
Yeah, please follow Gegels on Twitter, Gegels on Telegram, and yeah, Hinkel is live on 7 chains with all end-to-end experiences. So just plug in, open it up, and become private.
Yeah. And you guys, you can follow us from Twitter, Pado Labs, and also our website, padolabs.org. You can simply click that and can download our Chrome extension and then have a try about ZK attestation and ZKFHE as well.
Yeah, you can also follow our Twitter, and actually in May we will launch our mainnet of FHE restaking. So maybe you will be interested in staking into our restaking protocol.
Thank you very much. Thank you all for your time and the really good sharing. And I hope that you guys, have some key takeouts from here. So thank you very much.